And with that, we are ready to begin today's event, once again, hosted by Information Management, sponsored by Composite Software, ClickView, SAS, and Warescape, and benefiting Casting for Recovery. It's my pleasure to introduce your moderator for today, and that is Julie Langenkamp-Minkel. Julie, you have the floor.
Thank you so much. Welcome, everyone. Thanks for joining us for today's web seminar, Going Rogue, Disruptive Solutions for Tomorrow's Integration Challenges, sponsored by Composite Software, ClickView, SAS, and Warescape. My name is Julie Langenkamp-Minkel. I'm the Editor-in-Chief of InformationManagement.com, and I'm your moderator for today. Today's event is extremely unique for a number of reasons. First of all the proceeds from this webinar will be donated to Casting for Recovery Northern Oregon, which organizes fly fishing retreats for breast cancer survivors. Casting for Recovery was founded on the principles that the natural world is a healing force and that cancer survivors deserve one weekend free of charge and free of the stresses from medical treatment, home, or workplace to experience something new and challenging in learning the sport of fly fishing while enjoying the beautiful surroundings in an intimate, safe, and nurturing structure. Because of the generous support from today's sponsors and the coordination of today's event by Scott Humphrey, a $20,000 check will be made to Casting for Recovery. Additionally, today's thought leaders are donating their time and expertise for the cause, which leads me to the second reason why this web seminar is unusual. All 5 of our speakers are in the same room here. We are all at the Pacific Northwest BI Summit in Grants Pass, Oregon, on the Rogue River, hence the name of today's event. So it's a rarity to have so many thought leaders in the same place for a webinar like this, and rather than give formal presentations, we're just going to have a roundtable discussion with an open format. So please do submit your questions to us. We would love to take them throughout the next hour. We're going to chat about the future of integration, its challenges, and what to do about them. I'm going to begin with opening comments from each of our speakers and brief bios. So I will start with Jill. Jill Deshay is Vice President of Thought Leadership at SAS. She's responsible for industry analysis and education in the areas of data governance, business intelligence, and master data management. And she advises executives and boards on the strategic importance of investing in enterprise information. She's an author and popular blogger on the role of information in business. Welcome, Jill.
Hi, Julie. Nice to be here.
Great, thank you. Why don't you start us off by talking about why integration is such a challenge, or just frame the conversation for us.
Sure. Well, I think with the emerging trends of big data and NoSQL databases and federated data and the realities of all those things, integration is top of mind, not only with the people doing it, but with executives. And so I think we've got a lot of points of view here this morning, and it'll be a great discussion. Looking forward to the questions.
Thank you. Our next speaker is Claudia Imhoff. She is President and Founder of Intelligence Solutions and is a thought leader, visionary, and practitioner in the rapidly growing fields of business intelligence and customer-focused strategy. She's an internationally recognized expert on analytical CRM, BI, and the infrastructure to support these initiatives, the Corporate Information Factory. She's also the leader of the Boulder BI Brain Trust. Welcome, Claudia.
Well, thanks, Julie.
Do you have opening comments for us to frame the conversation?
Well, first of all, I do want to thank the 4 sponsors of this. It's a remarkable webcast. You're quite right. That's SAS, Composite, Warescape, and ClickView. And I, too, am very interested in everybody's different views. We come at this from very different angles and very different perspectives, so it should be a really interesting hour. So thanks to all the vendors, and thanks to Information Management.
Sure, my pleasure. Thank you. Our next speaker is William McKnight. He is a consultant, speaker, and author in information management. His company, McKnight Consulting Group, has attracted clients such as Fidelity Investments, Teva Pharmaceuticals, Scotiabank, Samba Bank, Pfizer, and France Telecom and Verizon. William is a very popular speaker worldwide and a prolific writer with hundreds of articles and white papers published. An Ernst & Young Entrepreneur of the Year finalist, William is a former Fortune 50 technology executive and software engineer. Welcome, William.
Thank you, Julie. Good to be here.
And what do you have to say? What are you looking forward to about this conversation, and what do you think we'll chat about today?
Well, integration and virtualization are what we can do with data to move it around to our queries and to the very many different heterogeneous data stores that we need today. And I think the headlines attest that data is becoming a very important asset, not only to business but to everything. And so we're sitting on that, and integration is very important to that.
Beautiful. Thank you. And now I'd like to welcome Sean Rogers. He's VP of Business Intelligence at Enterprise Management Associates. In this role, he delivers comprehensive coverage of the BI and data warehouse technology stack with a focus on database technology, data integration, BI management solutions, reporting, analytics, performance management, as well as emerging technologies such as SaaS BI, embedded BI, and social BI. Sean has more than 19 years of hands-on IT experience with a focus on internet-enabled technology. Welcome, Sean.
Thanks for having me. It's good to be here.
It's a pleasure. What can you say about the integration industry and the conversations the questions that you face?
You know, I think it's no surprise to anybody that's out there managing data that the landscape for doing that's becoming more diverse. Where we used to focus isn't as critical as it used to be. The EDW is not quite the pivot point or the center of the solar system that it has been for years. And getting data to and from all of these new platforms that are serving us in the data management landscape is a new challenge. And I think to the other points that have been made around big data, that just makes the challenge all that much bigger. So I think that's what will be a cornerstone of what we're discussing today.
Excellent. And last but not least, certainly, I would like to welcome Colin White. Colin is the founder of BI Research and president of Database Associates, Inc. As an analyst, educator, and writer, he's well known for his in-depth knowledge of data management, information integration, and BI technologies, and how they can be used for building the smart and agile business. He has consulted for dozens of companies throughout the world and is a frequent speaker at leading IT events, and has written numerous articles and papers on deploying new and evolving information technologies for business benefits, and is a regular contributor to several leading print and web-based industry journals. Welcome, Colin.
It's nice to be here. Thank you for inviting me.
My pleasure. And how about you? I know we've had a lot of opening comments, and I've seen a lot of nodding heads around as we've been chatting, but what are you hearing about the challenges with integration?
I think my fellow speakers have really said it all. What's interesting to me, I've worked in this industry, in the data management, data integration industry for several decades. I won't say how long, it's far too long. And I've also been coming to this event for about 10 years. What's exciting to me at the moment is the rate of change in the industry is most probably bigger than any other time I've seen it. Tremendous amount of change going on. And you know, over the time I've worked in the industry, data integration has always been a challenge, and most probably it's going to be the biggest challenge ever, given where we're at the moment.
Sure. So I'm going to use that as a launch pad for our questions. Colin, what do you think is driving that change, or that change that you're talking about? I mean, I know we've mentioned a couple of them here, but what are the prominent forces that are driving the changes?
Well, I think Sean was saying that the enterprise is no longer the center of the enterprise data warehouse is not just the sole piece in the middle anymore. We're seeing a lot of new technologies. We have this thing called big data. Everybody has different definitions of big data, but as I said, there's a lot of technology change going on, and whereas the enterprise data warehouse is still fundamental to what we, in terms of what we use for decision making, there are a number of other platforms that are being deployed, often associated with big data, that are also bringing sort of powerful business benefits to our organizations, and really making all those systems work together cohesively in a transparent way to our business users is very important. So integration is fundamental to that. So, you know, as I said, I think big data is sort of the driving force, but big data, you know, has many different sort of varieties and flavors, many different technologies. It's become almost a buzzword to represent the changes going on in the data management, data integration, and business intelligence industry. So it's moved beyond its really source of just simply web data. It means many more things now. And so to a certain extent, that is one of the big driving forces, I think.
Sure. Claudia, can you add to that? What do you see as the impact of big data on integration?
Well, you know, Colin's right. I mean, we're seeing now many different sources, I guess, unusual sources that we weren't used to in the prior enterprise data warehouse days. But I think what's interesting is that the technologies today allow us to bring in all of this data sort of unintegrated, if you will. We can kind of take a look at it. The problem that we have with big data is it's so much data, but there's also an awful lot of not terribly valuable data buried in there. So we need to be able to separate kind of the noise from the data that actually is of value. So what we've seen in terms of data integration is that we've now kind of reversed the process. We bring the data in first, kind of analyze it, figure out what's of value, and then what's of value we integrate into the rest of our BI environment. So we're not integrating first, we're integrating second, if you will, and doing some analysis to figure out what's of value and what's not. So it really has changed that whole landscape of data integration. When do I do it? Where do I do it? How do I do it? Has all been kind of shaken and put on its head a little bit.
Does anybody else, I mean, I want to open it up to the group. Are there more comments about that? Sean, go ahead.
You know, I think one of the other things that it's shifting right now is a demand by the end users, and I think also by the people that are running these systems for a greater level of agility and flexibility around the data. And we're getting some of that from big data because a lot of information that we would consider to be big data is entering our landscape or our ecosystems in a way that we used to fight around an enterprise data warehouse. We're not necessarily transforming, cleansing, cleaning. We're dumping the data into big data structures and then letting various users and applications and process have access to that information. So, you know, I'm sure part of today's discussion will be around where does data quality live in data integration today, and what about that need for agility and flexibility to move a lot faster to be able to change and make changes around our data. So I think that that's valid for this conversation as well.
Absolutely. So anybody else before we move on? William?
Well, I see another fundamental shift, and that is our users have more ability and more clamor. Like Sean was saying, you know, they want more data because they know how to turn that into bottom line profits for the company. So I see a shift from all these experimental big data projects to big data projects that are actually driving toward company objectives these days, because the data science within organizations has picked up to the point where they know what to do with all this big data now, more so.
I would love to come back to that, but I don't want to dismiss the data quality conversation that Sean just brought up. I think that that's a huge issue, and you mentioned that data is being dumped into these systems kind of without thought. And so I know quality is a big issue, but then, you know, making all of the data that we have fit together. Last night I was talking to someone who said that it's kind of like a big giant wastebasket, and all the data is being dumped in, and then trying to figure out how to make it all fit is a really huge issue. So where does quality play in that, and how do you make the data work for you? And so, Jill, is that something that you can speak to?
Sure. And it's interesting because it's a little heretical now in the days of integrating structured and unstructured data, you know, typical volumes of data and big volumes of data, to say that in some cases data quality might not be necessary, right? I mean, there is a huge case happening in some of the companies that we work with around just getting the data in, as Sean said, and exploring it in its raw form. And the patterns and correlations that emerge from that kind of work can be extremely valuable, irrespective of data correction. So we're seeing a trend toward that, and frankly, an executive willingness to sponsor and fund those kind of discovery activities against the big data. And so I think the challenge of integrating that data may or may not remain, irrespective of whether you're cleansing it. But very much data quality should be on a situational basis. What are we trying to do with the data, and how are we trying to analyze it? And that's when we decide whether, you know, how much horsepower and how many calories we're going to expend on cleaning up the data.
Yeah, I think it's a good point. I think what we're finding is that good enough data is good enough for certain things. It doesn't have to be pure. It doesn't have to be, you know, certified or whatever. It is good enough for certain types of analytics and so forth. And I think that's a really good, excuse me, a really good point. In the past with data warehouses, we were so knee-jerk about data quality. It had to be, you know, match everything. But there are so many things we can do today, especially with big data, that are approximations or estimations, and it's good enough. And that's what we need to remember.
But I think the other thing is, you know, I think in the past we've either had bad data or good data, and now I think we're moving towards shades of gray. You know, and you've got to decide, you know, which data is important, and it applies to security as well. You have to understand what data must be secure, what data must be clean, and then what data can sort of be perhaps in more of a gray area. But the important thing is the business user needs to know that. In other words, it's not only us, the IT, deciding which needs to be controlled and which shouldn't, or which should be good quality and which shouldn't. The important thing is for the business user to really understand which data is gold quality data and which isn't, and let them really make the appropriate use of that data and understand if it's good or bad in their decision making.
You know, the big data management is such a new territory, I think, for everybody. And we managed to do some research around it last year and found we were surprised. We thought we were going to get some really interesting use case scenarios about how people were leveraging big data. And we found that like 44, 45% of them were literally just using big data structures as an archive. An executive at a software company coined the phrase dumping, and it's very accurate, right? It's literally just dumping all of this stuff at the loading dock and then deciding how you're going to put it in a process or utilize it throughout whatever process that data is going to live in. To Colin's point, does it need to be pristine at the beginning, or could it be just good enough for what it is you need to get done? I think that part's interesting. It certainly speaks to the flexibility or agility aspect of what big data can do.
So data quality, Sean, is still the absence of intolerable defects. And I think that a lot of big data structures I see are dumping grounds, and their data quality needs to be improved in order for the data science to pick up where it needs to pick up. And architecturally, I'm in the camp that you will need to at least clean up and aggregate data into a structured format from Hadoop or your big data store into a relational database, which is increasingly an appliance type of database.
Well, and there's another aspect that we haven't really talked about. If we are going to open this up and say, gee, you can use the data, uncleaned data, whatever it is, I think we also need, IT or whoever, needs to be able to monitor the usage of that data, because at some point somebody's going to try to use it for something that should use good certified data, and if it isn't governed, it isn't certified, and they're using it for, let's say, a compliance report or a regulatory report, there ought to be flags going up somewhere. So I think we also, it's the Wild West, okay, we can use the data, it's not as clean as we'd like or whatever, but I think we also need to recognize that people may use that information for things that perhaps they shouldn't. And we can't control it, but we certainly can monitor it.
Maybe more scoring of the data.
Scoring, I like that.
But I think the other thing is what we're seeing is a lot of our decision-making systems, be they enterprise data warehouses or appliances, are being front-ended by these data refineries. And as was pointed out, the volume of data coming in is quite voluminous in many cases, and a lot of that data is of no business value. It's technical data that's purely of little value for the business. So the refinery's job is to extract the actual data of business value, and that's when you start looking at the quality. Once you've extracted that value, then you've got to start applying governance and quality procedures to that data, and then we may actually downstream that data into an enterprise data warehouse. So I think what we're seeing in many cases with these new systems, we're front-ending the EDW with other systems to actually blend data together, investigate it, even analyze it in some case, and to extract business value from that, and then that feeds out existing downstream decision-making systems.
So one of the comments that came in here is that traditionally data scientists don't want other people doing data quality on their data. They want raw, unadulterated signal from the systems. Is that what you guys are seeing? Or, I know it contradicts what William said, and I see a bunch of hands going up here. Do you want to kick it off?
Well, at a very, very high level data scientist, yes, maybe that is true, but they're going to take that data and do a lot of their own processing. Isn't that them doing the data quality to it? They do need the data quality. It's just a matter of who does it.
Well, and I think again, it depends on what they're doing. If they're looking for just approximations or estimations, or they're just trying to predict something using this information, then maybe it doesn't have to be pristine. But I think, again, if they're trying to do something that the company is going to rely on, financial reports or whatever, I think that will change the complexion of the need for data quality.
Yeah, and I do think it is about the context of usage. I mean, looking at a customer's shopping behaviors around your store through their, mobile device, it's going to have a different set of processes and policies around it than, a patient's health records might. So I think we have to look at the data in the context, and I think, back to the integration discussion, it's interesting because we find that a lot of companies are trying to put policies around all of their data. Well, what's our policy on our data? When in fact, there really does need to be, and I think we have a drinking game for this word, there really does need to be a taxonomy around data categorization. What is our sensitive data? What is our private data? what is our generally available data? And I think once we start to assign categories around data in terms of security and sensitivity, we can monitor the behaviors, as Colin said, much more effectively.
Yeah, I would add that on the end of usage, whether it's a data scientist or a standard sort of business user or a discovery type user, there needs to be different architectures or different platforms or solutions for that. And I think we've seen some very successful large implementations. eBay comes to mind with their 3 analytic kind of worlds where they serve out of one a high concurrency rate of thousands of users all the way out to the one that they supply for their data scientists, which if I remember correctly from that use case was only 5 concurrent users on an immense amount, multi-petabyte type framework. So I think that that's also part of the challenge right now. And then the question becomes is, do you need to integrate between those 3 worlds if you've set up 3 worlds like that, and then how do you manage the data between them and so on? So.
But I also think it's like if you go back to the days and continuing now when we build transaction processing systems, we kind of had a test environment and a production environment. So we had to think of the EDW in our existing system as being our production environment, and then we actually have a testing or investigative environment where we are blending data together, and that's where the data scientist fits in, when they're doing a lot of more work up front. And there they may not want high quality data, but as they manipulate that data, as they decide what data is of value, then you want to move it over into a production environment. So I tend to think we need to start thinking more of the EDW and its associated systems as being a production environment, and many of the other platforms that the other speakers have been talking about that data scientists may use as more investigative or data refineries, which are more testing and development environments where we're looking for agility in development and actually quickly extracting business value out of this data, and then we can push that data into a production environment.
So, Sean, you raised a number of questions about, how do you solve those? Do you integrate all those different areas? And if somebody is looking for answers about where to get started with integration or how to address the question of whether or not to integrate those different areas, what advice do you give them?
I think a couple of years ago I would have said, well, you need to spend a lot of time scoping the project and understanding the use and so on, and I think that parts of that are still very valid. I would probably fall back now on, I guess, maybe a more macro way of looking at it and take a look at the architecture you have and make sure that it gives you the flexibility to manage data perhaps more differently than you have in the past. It used to be very linear. There was a data source, and then there was all these steps between the data source getting into your ecosystem for utilization, and some of that was data quality, and some of it was data transformation, and so on, and it finally was pristine enough to be in the system. That was it was a very rigid process, and now I think we're persisting data in different places. And not to take us too far off track, but we're applying even schemas to data in a very much a different way than we used to. We used to bring the data directly into a pre-designed model and keep it that way, and it was very difficult to make changes. Now we want more flexibility. So I guess if I was going to give advice to somebody today, I would actually stand a step further back and look at their overall landscape and start a discussion around agility, flexibility, and making sure that you have the right tools in your hands to do things. The old hammer of ETL is fine under certain circumstances, but we are using a lot of different tools nowadays, and I think that I'd be interested to hear what everybody else has to say about flexibility around tools and approaches. But to me, I think it's an architecture thing at this point. You really have to have a flexible, agile way of doing data integration and handling your data, because it's a bigger asset than it's ever been before.
And I think, we use the word data integration. I like the word some vendors are using now as the concept of data blending. In other words, ETL and that, the whole point of ETL was to come up with predefined schemas, and that's data integration. Whereas what I think we're now starting to do, to carry on from Sean's point, is more data blending, where we've got dynamic schemas. We don't predefine the schemas, we build dynamic schemas on the fly as we access the data, and that's more blending different combinations of data till we find a combination of value to the business, and then we may move to a more formal environment where we integrate that data. So I think I like the word data blending because it sort of implies this sort of flexibility, dynamic approach to building schemas. We don't have to predefine all the schemas up ahead of time before we can start analyzing the data.
Well, and I want to, first I'll plug a research report that Sean did at EMA Research with John Myers called the Hybrid Data Ecosystem, because I think that was a very visionary way to start looking anew at platforms and getting the data in and out of those platforms in a sustainable way. And I think that's particularly interesting for IT-led integration efforts and big data efforts. Increasingly, we're also seeing business-led efforts where the platform may not actually be, the primary discussion point for somebody in marketing or somebody in finance. But it's interesting because those guys have their own budgets for integration now. They've got their own line of business IT budgets, and so they're not only looking at things like technology, they're looking at things like the cloud, they're looking at things like kicking up their analytics capabilities, and they're looking at doing a lot of the work themselves. And so back to your question, Julie, of where to start, I would say, look at the need, pain, or problem and start looking at some of the gaps.
I just want to get out there, since we're talking about data integration and big data, that just because you're deploying a Hadoop-based architecture doesn't mean you're not doing ETL anymore. I have many clients that are sticking with ETL because for that ETL piece, they don't want to take chances. They're used to their ETL tools, and so they are being carried forward into this environment. So that is still a very legitimate way of integrating data into big data.
Oh, we're not replacing anything, are we? We're evolving.
I think we're augmenting, right?
Yeah.
So that actually aligns well with one of the questions that came in. Some popular tools being used in big data, like Hadoop, address data in ways that are incongruous with most data warehouse architectures. What are 2 or 3 of the most common methods leaders use to bridge Hadoop to the traditional EDW?
Yeah, you have to go back to the problem with that, but what we're finding increasingly, and again, this may be heresy, we're finding data warehouse data making its way into Hadoop more and more, and because of all the new big data solutions out there, it's more and more practical to actually use Hadoop as a source for analytical data. So, that's actually a trend. Obviously, there are many models for that. There is also the data warehouse as the consumer of Hadoop data. But we're finding with the increased flexibility of Hadoop through these open source projects, that seems to be the newly persistent solution for integrating heterogeneous data.
Well, and I think, again, back to what Colin said, a lot of people are using their Hadoop environments as this kind of refinery. Let's put the raw data in, let's figure out, analyze it, look at it, make sure that we understand what it's doing or what's of value in it, and then put the valuable stuff, perhaps, integrate it and put it into our EDW, into that production environment. So it's kind of the difference between the raw refinery side and the production side. I like that model. I think that doesn't muck up the enterprise data warehouse with data that's unnecessary, and it does give us a very useful, very fast way of figuring out what's of value and what's not of value. A good combination, a good way to integrate those 2 environments.
But I think there's 2 models really. One model, as Jill was saying, is you may use Hadoop as an analytical platform, or the other model is you bring the data over into a relational system. So from a business user viewpoint, they may be simply accessing the EDW, or they may be accessing both a Hadoop system and the EDW system. The key thing, though, from a business user viewpoint, they shouldn't have to care. In other words, the user doesn't care stuff where the data is. They simply want a common interface to these back-end systems, and I think that's what the vendors are now starting to look at. It's like we look at data virtualization. The role of data virtualization has changed. To me, one of the big advantages of data virtualization is the common semantic front end to the data the business user needs to make decisions. If that's data in a Hadoop or an appliance or EDW, they shouldn't have to care about that. Our job as IT people, or if you like, is to decide the appropriate platform for the appropriate analytic workload and put it there. And if we have to move data between the platforms, then so be it. But really, the end user shouldn't have to care about any of that.
I think to expand on your comment about data virtualization as an asset to these types of environments is right to what you just said. Data virtualization doesn't necessarily cause you or require you to move data. And oftentimes a large investment has been made in matching workloads and data types to specific platforms, and it makes better sense to have that platform work on that part of the problem and then maybe piecemeal it together with another platform and so on. And that just speaks to the complexity of the questions that we're asking of our data today, which has also evolved as much as the amount of data has. The end user community, to William's point early on today in the discussion, is that they're much more mature and they're asking better questions, but asking those better questions doesn't mean that they want to understand how we're making the sausage. They just want the output. They don't want to know that it came from 3 different platforms and what needed to be done to get all of that together. And I think that that's pretty key to serving people today.
And I think to carry on from your point, there's too much focus on the data itself. The 3 V's to me, yeah, they're okay, but it's what you do with the data that matters. It's the analytics you generate from the data. So we need to focus far more on what we do with the data as opposed to the data itself.
5 V's, Colin.
5 V's.
It's actually 10.
Is it 10?
Yes.
So you raised the comment about analytics and what we actually do with the data. Do we need a special environment to do analytics on big data? And I know that this might get away from the topic a little bit, but let's just chat about that for a moment. William, can you speak to that?
Well, analytics permeate so many different applications today. I mean, a lot of them need analytical type data, which is data that's summarized from transaction data and brought back into profile type data. So it adds on to like a customer dimension would have customer lifetime value, propensity to churn, and things like that. Those things can only realistically be gathered by scanning a lot of transactions, not only that customer's, but a lot of other customers' transactions, so for patterns and so on. So like I said before, I'm really in the camp that needs to get done today, at least, in the relational database world, not in the big data world. Big data world is great for loading that data that forms the back end of the analytical data, but a lot of that processing still is getting brought over to the relational world, and a lot of that's in appliances, like I said before.
I just finished a report earlier this summer with Tom Davenport called Big Data in Big Companies, and what was interesting is we interviewed 20 different companies about what they were doing with big data, and these were big companies. And to a point, everybody said, we are no longer relying on our incumbent technologies to try to do this work. Every company had acquired some new solution, some new open source project, some new platform in order to solve their big data issues. So what was really interesting is that the big data technologies that all these companies were using were either additive to their incumbent technologies, as Claudia said, we can leverage our data warehouses, but increasingly we're finding that they were replacing some of their incumbent technologies with some of these big data technologies as well. So to the question of, do we need specialized platforms, I think what we're actually seeing from the early adopters is they are acquiring specialized platforms to do this high performance work.
Yeah, one size fits all doesn't work anymore. In other words, we're going to deploy platforms that are best suited to the complexity of the analytics and the complexity of the analytical workload.
Well, I think, as I said earlier, I think a lot of big data is noise, as you said, Colin, as well. It just simply isn't valuable. So why do I want to put that into my data warehouse? I would rather analyze it in some specialized platform that does give me incredible performance and scalability and everything else, and allows me to figure out what's of value and what isn't of value, and then move that in, perhaps. But
I think the other important thing is your definition of big data. William was talking about relational appliances, and that, to me, that's still a big data platform. In other words, what happened was we developed a bunch of technologies, particularly in the web environment, that gave us high-performance processing against multi-structured data. What we've done, though, is taken a lot of those technologies and put them into our existing environments. In other words, even if you don't want to access web data, even if you haven't got high data volumes, even if you haven't got multi-structured data, a lot of these big data technologies, particularly in some of the advanced analytics we've been deploying with analytical appliances, are equally applicable to to what we do today. So the way I tend to look at big data is it enables us to improve what we do today, and then secondly, enables us to extend what we do today by bringing in other sources of data and evolving our analytical environments to do more sophisticated things. But big data applies equally to what we do today. There's a lot of technology simply improves the performance of what we can do. We can run risk models now, traditional risk models, in a matter of minutes, whereas a few years ago they took hours. And the data is the same, the processing is the same. It's that the underlying technology that's been built to support big data can be used to improve what we do today.
You know, just to add on to the conversation around these multi-platforms, we were curious as to how diverse the landscape was getting with the end user community, and we found that 53% of the folks that had answered this type of a question in some of our research indicated that they were dealing with between 3 or 2 different nodes or solutions in their data management world. So they either had cloud and an appliance and an EDW or some other version of all of these different specialized platforms for solving these problems, which, you know, getting back to the core of the discussion today, starts to make for a very interesting data integration challenge.
Sure. So I know that there are a lot of, I'm going to shift gears for just a minute here. It seems like a lot of the problem of IT trying to keep up with the needs of the business, not just with big data, but when it comes to all data, do you agree with the fact that, or with the observation, I shouldn't say fact, do you agree with the observation that IT is trying to keep up and that business is really requiring more of the data? And why does that problem persist after all of these years? Sean, I'm going to field that one to you first.
You know, well, I think that there's a lot of change happening in the IT environment, and IT is certainly feeling an awful lot of pressure from end users. And I think there's sort of 4 undeniable things at work here that are causing the shift, and I think causing them to try a lot harder to better serve the demands of end users. The demands of end users are becoming more sophisticated. Our customers, if you have your IT hat on, they've grown up quite a bit, and they want to ask tougher and harder questions of the data that they have access to. We've democratized the BI applications. More people have the tools now, so they're putting more of a crush onto the environment. And these older, more traditional environments weren't really built for this, so that gives IT an awful lot of work to do. Economically, I think the dollars are driving the opportunity and the challenge as well. We can now do work at a cost level that we couldn't do 10 years ago at that cost level. Big data has probably been around a lot longer than anyone wants to admit. For me, we used to see sort of, you know, quote-unquote big data projects that were done in a room full of Cray supercomputers with a federal grant. So the economic aspect of it was pretty important. Now, smaller companies can afford to do it, so IT has to pay the price for that. The third part is new technologies, and Hadoop and other big data solutions and NoSQL solutions are driving us to change and to do things in a different way, and are opening more opportunities and causing IT to have to keep up there as well. And the fourth bit is back to the data, and I agree with Colin. It's not about the data, but with that said, we're able now to utilize data that we were forced to ignore before. Everybody's read an article about 80% of corporate data was just too difficult to get into or to utilize, and we couldn't get value from it. Now, with all of our abilities around unstructured information, we're able to go after the data that we were forced to ignore before, and we're having fun with new data sources like social data and so on that have found their way into the enterprise. So when you look at all 4 of those things, frankly, I think IT's got a really tough job to do, and I think that they're very much being put to the test, not just around data integration, but to handle all 4 of those drivers as they hit them.
Well, I think the other problem that I see, too, is that it is a very disruptive time right now, and I think we have a lot of innovative technology. We have a lot of really cool stuff. The problem is that a lot of IT people don't know when to use what kind of technology. The questions I get from clients is just, when do I do this Hadoop thing? You know, what kinds of business problems do I solve with this? And I think we as industry analysts and consultants, we need to rethink a little bit about maybe simplifying or getting a message about when do we use these things and when do we not use them. I think there is just a tremendous amount of confusion in many of the corporations today. They don't know. We've sort of upset their apple cart, and they really don't know which technology do I use for which kind of business problem. And that's, that's causing IT to move into kind of an analysis paralysis type of mode of they're afraid to jump because they're afraid they're going to pick the wrong technology, which, that's our job, is perhaps to help them understand when and where to use what kinds of technology. Just a little heads up, I thought I'd put it right out.
The only other comment I would make there is there's pressure on IT to reduce costs, and therefore they start to look at using, white box hardware. They start looking at the cost per terabyte. What they don't look at is total cost of ownership. In other words, it may be quicker to put in a bit of white box hardware because it's cheap and the cost per terabyte is cheap. But if the technology you're putting on that takes more time to develop, more resources to develop. So you've got to match your skills to the platforms as well and look at the total cost of ownership of these systems and relate that to the business benefits you're getting back. In other words, there's no point in just taking all this data and dumping it in the data refiner and saying, now what do I do with it? This back to the days of when we build EDWs. We build EDWs to say, well, we'll put the data in the EDW and the business users will come to it. We've proved that doesn't work. And it's the same with these Hadoop systems, just taking all this data and turning a Hadoop system into a data refinery. That's not sufficient. You've got to look at very specific business projects and weigh the total cost of ownership of building one of these systems against the business benefits you're going to achieve by deploying them.
Well, and I do think it is a business issue. I think the rise of shadow IT and the fact of line of business IT budget means that IT is increasingly in a follower mode and not a leader mode. But I do think, having said that we have to cut IT a little slack, because I think one of the main problems, I like to say there's nothing more dangerous than an executive who's just read an airline magazine. The business is coming out and saying we need to do this big data thing, whatever it is, and the communications and rules of engagement between IT and the business are still squishy, and those aren't improving just because we're now doing big data. So I think part of the problem is that endemic relationship and those rules of engagement, or lack thereof, between the business and IT. And what we're seeing with some of our customers is that big data is driving those conversations anew. Like, if we're going to start doing this and we're going to make these investments and we're going to start hiring data scientists, everybody take a sip of tequila, then we need to formalize some of these communication structures a lot more effectively, particularly since maybe for the first time we're actually going to be sharing budgets on this stuff.
I think IT is definitely beleaguered, but they're often put in between a rock and a hard place, because the business suddenly wants big data, whereas they didn't want to engage the conversation when IT was ready for it 6 months ago. And IT is definitely getting distributed into little pieces all throughout the organization. So collectively, they're doing a little bit better, I think. They're doing a little bit better bringing ideas, but it does come down to leadership of individuals within the technology groups within these organizations to get out there in front of the business.
Great. One of the questions that came in is, are disruptive solutions synonymous with big data, or are there other dimensions to disruption?
Well, I think, if you...
It's a good question.
If you look at several of the vendors, they all say the same thing. But, if you look at disruptive technologies, they are things like big data, yes. The cloud is another one. Mobile is another one. So there are several disruptive events going on in our industry at the moment, not just big data.
Yeah, I mean, self-service BI is another. There are many things going on. I think a lot of it, big data has certainly been the marketer's dream, and it's something that we've all kind of latched onto as a catch term or whatever. But I think there's innovation and incredible disruption in all aspects of business intelligence now. Look at streaming analytics. We didn't even know what that was, or at least those of us in the BI world probably didn't even know what it was 5 years ago, and now we're all talking about operational intelligence and that sort of thing. We're talking about experimental or sandboxes. We didn't have those either. So I think it's more than just big data. There's a lot going on right now. It's an incredibly innovative time in business intelligence. With disruption comes a lot of confusion. So eventually it'll work itself out. But I think right now it's very innovative and it's very disruptive.
Well, and I think disruption is in the eye of the beholder to a certain extent. I mean, Hadoop is a very disruptive technology at some older established companies, but it's foundational technologies for some newer companies. So, you know, I do think you have to look at your culture and your incumbent environment to determine what is disruption. But, you know, to answer the question, you know, a spreadsheet can be a disruptive technology. So it's not necessarily all about big data.
I think we've even talked about what I feel is the biggest disruptor, and that's cloud computing.
Yeah, I think
that's the biggest disruptor to what we do in information management as well.
Sure. And now, I'm surprised that it took us this long to get to that. Can you talk a little bit about how that's disruptive, the challenges with integration related to cloud computing?
Well, it just exacerbates the challenges with integration, doesn't it? And if you don't have an architecture that you follow so that you coexist data that's going to need that level of integration into clouds, into a single cloud, that is, instead of multiple clouds with data all over the place, you're just increasing your data integration requirements right there.
We have 10 minutes left, so I want to frame that in terms of our next answers. But one of the questions that came in was, how do you see code generation and automation tools fitting into the landscape, and are they required for success going forward?
Well, sure. I mean, I think the answer is yes. They are needed. We're certainly not going to go back to the dark days of no coding or hand coding things. So yes, of course they are. I think automation in this sense is very necessary. We've all talked about how agile things have to be and how fast we have to be, flexible and so forth and so on. You're not going to get that unless you have some kind of environment that is automated in that sense.
Well, hopefully we've stressed today that we have a lot of work to do in information management, and to do that and accomplish our goals, we need to be agile. And in order to be agile, you need tools that are well-performing, get up and running quickly, and incorporate lessons learned of the past decade in data warehousing. And so data warehouse automation tools incorporate these learnings and allow us to get a jump start at getting functioning data stores out.
I would just also make a point that, you know, we've talked about the building blocks here, whether it's Hadoop or an integrated hybrid type system. We're starting to see an awful lot of the bigger vendors in the space, the IBMs, SAPs, and so on of the world, Teradata, all starting to create ecosystems of their own where they're putting together different platforms within sort of a highly integrated envelope or structure. And those need to be automated because the decisions are becoming, where does the data best belong? How do I integrate the data from A to B to C? And I think that that's the challenge that from an automated side for the vendor community right now to see as a large opportunity is, do you build a behemoth stack that's highly integrated that has lots of bits and parts to it, or are best-of-breed solutions the best way to go? And if they are, then how do you interconnect those, and how do you weave those technologies together? And I think we're at sort of a crossroads where companies are going to make that decision moving forward, that they're either going to dedicate themselves to a stack because they like the ability to put this envelope around it, or they're going to continue with best of breed, and they're going to have to find solution providers that help them automate decision, automate processes, automate data management issues in a way that they can't do manually.
And really there's two areas here. One is the analytics side, and definitely, particularly as we go towards closer to real-time decisions, we need automation there. From a code generation viewpoint, really looking at data integration, if you look at the history of data integration, the competition has always been write your own code versus actually code generators or automated tools for doing ETL. That's still the case today. And if you take some of the data integration vendors, their biggest competitors roll your own. Let's take Hadoop, for example. Hadoop is a very Java-based environment. Even if you look at the use of Hadoop in traditional companies, where it's been most successful are companies that are very Java-based with a lot of Java programmers. If we're going to extend these new technologies to a broader set of developers, a lot of those developers aren't going to be Java experts, and therefore we are going to need automation tools, data warehouse automation tools that can support those environments. And again, we're back to the same thing again. Do we actually code it ourselves, or do we use automation tools? And the answer is yes, you do both. But at the moment, what we're lacking to a certain extent with these new technologies is a lack of automation tools. It's a lot of hand coding involved, and that's why I come back to the total cost of ownership. If you've got lots of Java programmers and they've just left college, that's pretty inexpensive. But on the other hand, if you're an established company with old fogies like me, then we're expensive. So we need automated tools, right?
I feel like we're back 20 years ago of justifying why do we need an ETL tool.
We are.
I know.
Nothing changes.
Nothing changes, but we justified it then. We're justifying it now. Of course, we need automation. Of course, we need these productivity tools. We need the documentation that goes along with them. So nothing's changed. It's just a different world.
And yet it's game-changing technologies that we're talking about here. So, some things change and some things remain the same. But I was curious about how these technologies, these disruptive technologies, are changing the skill sets that are required in an organization. Do you need more specialized people? Do you need people who are business savvy and data savvy and understand math? And, how does that change the job landscape of the people that you need within your organization to handle the integration challenges and all of the big data requirements?
Well, I think that's part of the analysis paralysis that I talked about. I think that we do need to think about simplifying this environment, and automation is certainly one of the ways of doing it. Do we need people that understand, that can do data engineering? Of course. Do we need data scientists? Yes. It's probably not every single person in an organization. It's probably a handful of them. But there's certainly someone that we want to have in our enterprises. The vast majority, though, of BI users are still relatively technologically naive people. They don't need to be data scientists. They just need the results of whatever the data scientists are creating for them, or the business analysts or so forth. I think, the buzz term data scientist, and, it still says, take a shot. I think it's like big data, take another shot. It's a lovely marketing term, but the reality is, there aren't that many out there, and there aren't that many that are needed within an organization. So I think we need a little reality check there.
But it's back to Jill's point of putting some structure on this, in the sense you're not going to have one person with all these skills, so therefore you have to build teams of people with different skills, and therefore you need to put some structure on it to actually establish these teams. You can't just have a random set of people. And, companies are going out, and we need a data scientist. Well, define what a data scientist is, but if you look at all the skills, you need data engineering skills, you need statistical skills, you need analytical skills, and the key thing that separates a data scientist from, say, a data miner in the past, they need strong business skills and business knowledge of how to apply this. And finding one person that has all those skills is incredibly tough. Therefore, you build a team of people.
I would just say that I think testament to the skill gap is how much we're seeing in the marketplace now of leading vendors are starting to invest in enablement and education. Turn your team into the data scientists that you need, use the talent that you have in a house to leverage. And then at the same time, I've seen a major uptick in the university and academic side of our world looking at this as an opportunity. And many of the universities that have always addressed business intelligence as an opportunity for education and so on are now starting to look even deeper at putting analytic programs in place, business intelligence master's programs, specialty certification programs, and so on. I've talked to more academics and more universities over the last year than I have in my career, and it's all been about how do we go about filling this skill gap and creating opportunity.
And I'll just add that if you go to any big data conference, everybody's talking about platforms, everybody's talking about analytics, everybody's talking about data scientists, but nobody's talking about data management. And so I think the main skill gap is people that understand things like data definitions, metadata, business rules, data correction processes. And we can't, as Colin said, we can't lump those all into the rubric of a data scientist. It's a specialized skill set.
Well, and I think it's also, we got to get away from the technological talk. We need to get back to the business and say, what does the business really want? The problem that many people have with the big data push is that it's such a technological discussion instead of a business discussion. Hadoop, who cares? It's what am I going to do with this data? It's not the technological talk that we ought to be having, it's the business talk. And do we need a data scientist? Do we need people with these skills and so forth? And what are we going to do with these skills once we get them?
And for that, Claudia, I think we sorely need good leadership over all these decisions that now need to be made in the technical areas around information management. So I would say the skill lacking is leadership.
Yep, back to the business.
Excellent. I want to wrap up. We haven't talked very specifically about solutions or tools, but I want to give a shout out to our sponsors, definitely. And I would love to wrap up and just have everybody talk really briefly, maybe 30 seconds or so, about each of the sponsor vendors that we have here. Claudia, would you kick us off and just comment on ClickTech and what they're doing?
Oh, sure. I would love to comment on ClickTech, ClickView. One thing that is really exciting is they are coming out with their next version. It is called Next. It'll be out later on this year, and I do recommend that people take a look at it. I've already seen it. Fortunately, I've gotten a preview of it, and it is remarkable. The other thing that ClickView has done is they bought Expressor. And so now they have the ETL capability as well. They are really filling out the full suite from start to finish. It's not just a BI tool. They now have a lot of capabilities under the covers that make, talking about automation, that make it much easier to create the environment for the, analytics to be performed. So, hats off to ClickView for what they're doing.
Excellent. Colin, would you talk about what SAS is doing?
Yeah, SAS has always been a great company to me. I've worked and looked at SAS ever since I've been in the industry. They've been around a long time. And often they kind of sit in the background, and when you start digging into SAS, you find really a lot more there than you suddenly realize. You won't think of it simply as a 4GL analytical type tool, but if you dig beneath the covers, there's some tremendous technology going there. Perhaps the exciting thing they're doing to me at the moment is their laser server, which is this in-memory analytical server, which actually can be deployed standalone or can be deployed in a Hadoop environment. And the performance they're getting out of that server for analytics is quite incredible. And so if you look, and they're starting to migrate many of their applications. And I think the other interesting thing about SAS is we tend to think of them as a tool, but as we start to do more sophisticated analytics, I actually think that the key to success are going to be pre-built applications for specific domains. And certainly, if you look at SAS's revenue, they're getting significant revenue in certain specific domains like risk management, money laundering, and so on. So if you take their direction towards providing sophisticated analytical solutions for particular areas and then sit that on top of a laser server, I think they have an interesting future.
Great, thank you. Sean, would you comment on composite software?
I've had the pleasure, I guess, of covering them for quite some time, and it's been interesting. They've definitely positioned themselves as a leader in the data virtualization segment, and I think proof to that, or testament to that, is the company was recently acquired by Cisco. Cisco obviously has challenges in their ecosystem of operational and network information. I'm sure that they'll be utilizing composites technology in an interesting way there. They have a track record of significant product releases. They're constantly upgrading their overall data virtualization engine for speed and flexibility. And so for me, we counsel our end users often that data virtualization is a tool that they need to have in their lineup. And I think that Composite's done a good job of addressing the evolving needs. And I think they're also benefiting from a market that's swinging towards them in demand of that. So good for them.
Great. And William, would you finish up with Wearscape, please?
So sure, Wearscape is a tool that is a data automation tool that incorporates a lot of learning that we've had in data warehousing over the past decade. And what I really like about it is that you can go from thought to implementation in production very quickly. And you can modify accordingly once you're there, of course. But a lot of the agile methodologies that companies are stepping up to in our space, they're having challenges with that because they really can't get full life cycles done in the matter of a sprint. And tools like Wearscape really help you to do that. So if you're going agile, a tool like Wearscape can be very helpful to that strategy.
Beautiful. Well, I want to thank all five of you. Thank you so much for your comments and expertise. This has been great fun for me. I really love watching all of this come together, and I hope that everybody enjoyed the comments. Thank you so much for participating in this web seminar. I also, of course, want to thank Composite Software, ClickView, SAS, and Wearscape for their marvelous sponsorship for the benefit of Casting for Recovery. Thank you so much, everyone, and have a great day.